Come on, my dears, let us today finish the exercise numericals. Kindly read the statement of first numerical. Come on, have you read it? Tell me. They are talking about fourth order dark fringe. Fourth order dark fringe. Dark fringe means zero intensity. Zero intensity means destructive interference. Destructive interference means path difference should be 2n minus 1 into lambda by 2. But what was the formula for path difference? It was x into small d upon capital D. Fine. And that should be equal to, come on, 2n minus 1 lambda by 2. Instead of x, I am just putting xn. N is a suffix, you must write it below x. Okay, fine. It indicates order of dark fringe. Come on. We are given fourth order dark fringe. Fourth order dark fringe. So put n equal to 4. So it will give you x4 into d upon d. Put n equal to 4. 4 to the 8 minus 1, that is 7 lambda by 2. What is x4? Distance of fourth order dark fringe from central bright fringe, which they have given, come on, 3 millimeter. Convert it into centimeter, multiply by 10 raised to minus 1. Come on, what is small d? Distance between two slits, which they have given 0.7 millimeter. Again, convert it into centimeter, multiply by 10 raised to minus 1. What about capital D? Distance between slit and screen, which is 100 centimeter. And that equals to 7 into lambda upon 2. 7 into lambda upon 2. Find out lambda from here. You will get the value 6 into 10 raised to minus 5. This many centimeter. Because other distances we had taken in centimeter. But now generally it is a tradition to find out lambda in angstrom. So let us convert centimeter to angstrom. Don't you know 1 centimeter is 10 raised to plus 8 angstrom. Don't be cheated. Angstrom to centimeter, you should multiply by 10 raised to minus 8. But centimeter to angstrom, you should multiply by 10 raised to plus 8. Centimeter to angstrom, multiply by 10 raised to plus 8. Come on. 8 minus 5, that is 3. 10 raised to 3, that is 1000. 1000 into 6 will be 6000 angstrom. Okay, fine. Kindly read the statement of number 2 now. Read it. They are asking distance between third order bright fringe and fifth order dark fringe. What is the distance? Let us find out. Come on, first of all, take third order bright fringe. Bright fringe, maximum intensity, construct interference, path difference should be n lambda. Path difference is xd upon d should be equal to n lambda. Instead of x, I am putting xn. N you should write as a suffix. Now put n equal to 3 here. So it is x3 into d upon d, and here n equal to 3, so it is 3 lambda, because they are talking about third order bright fringe, that's why. Find out x3, transfer this capital D, transfer this small d. 3 into lambda into capital D upon small d. Give it equation number 1. Now they are talking about fifth order dark fringe. Dark fringe, zero intensity. Dark fringe means zero intensity, destructive interference. Path difference should be 2n minus 1 into lambda by 2. Path difference is xd upon d, that should be equal to 2n minus 1 lambda by 2. And now put n equal to 5, because they are talking about fifth order dark fringe. N equal to 5. N equal to 5. 5 to the 10. 10 minus 1, that is 9. 9 lambda by 2. 9 lambda by 2. And now we want x5. Transfer this capital D, transfer this small d. Give it equation number 2. Now this is the bigger distance. This one is smaller distance. We are asked to find out distance between fifth dark and third bright fringe. So you should find out x5 minus x3. x5 minus x3. This minus this will give you this minus this. Come on. When you take this minus this, lambda d upon d can be taken common. Inside the bracket 9 by 2 minus 3. Come on, 9 by 2 minus 3. Come on, lambda d upon d as it is. Take LCM, it will be 2. 2 3 is 6. 9 minus 6, that is 3. And now tell me lambda wavelength, they are given 5000 angstrom. Convert angstrom into centimeter, multiply by 10 raised to minus 8. What about capital D? Distance between slit and screen, which they are given 100 centimeter into 3. Don't forget, small d is distance between two slits, which is 0.05 centimeter. These two as it is. Simplify, answer is 0.15 centimeter. Okay, so this gives you distance between fifth dark fringe and third bright fringe. Fine. Now read the statement of number 3. Read it? Come on. Wavelength of first light, which they are given 4000 angstrom, and in that case fifth order bright fringe is obtained at a particular point on the screen. Now come on, bright fringe, maximum intensity, construct interference, part difference should be n lambda. Part difference is xd upon d, that should be equal to n lambda. Because they are talking about fifth order bright fringe, I should write n equal to 5, n equal to 5. Now find out x5, transfer this capital D here, transfer this small d in the denominator. So 5 lambda capital D upon small d. Give it equation number 1. And now we are given some unknown light for which wavelength is not known to us. We have to find out, let it be lambda dash. But when we use another light, at that time at the same point which was mentioned earlier, where fifth order bright fringe had taken place in case of wavelength 4000 angstrom, at the same point on the screen we are getting now fourth order bright fringe. Fourth order bright fringe. Bright fringe, construct interference, part difference should be n lambda. So part difference is xd upon d, and that should be equal to n lambda. But because we have changed the light, lambda I should change from lambda to lambda dash. Lambda dash is the wavelength of new light which we have to find out. Come on. Because they are talking about now fourth order bright fringe taking place at the same point which was mentioned earlier, then you should write n equal to 4. N equal to 4. Come on, n equal to 4. Fine. Now x4 d upon d should be equal to 4 lambda dash. Find out x4. Transfer this capital D, transfer this small d. Come on, give it equation number 2. And because the fifth order bright fringe while using first light and fourth order bright fringe while using second light, because they both are obtained at the same point on the screen, whatever is the distance of that point from the central bright fringe, that distance is constant, same. So whatever is this distance, same is this distance. Then only you can say they are superposing on each other. So here what is given to us, x5 and x4, these two distances are given to us equal. So here given to us is x5 equals to x4. But this equals to this means this equals to this. That's what I have written here. Now come on, capital D will be getting cancelled, small d also. Find out lambda dash, it will be 5 lambda upon 4. 5 lambda upon 4. Come on, 5 as it is. What about lambda? Wavelength of first light, come on, 4000 angstrom divided by 4. 4000 upon 4, that is 1000. 1000 into 5, that is 5000 angstrom. Correct? Because this is taken in angstrom, this also will be found in angstrom. Kindly read the statement of number 4 now. Read it. Here are the two slits in Young's experiment. In front of the slits we have got this screen. In the initial condition it is at distance d1 from the slits, and now this screen is displaced 50 centimeter further away from the slit this way. So this displacement is 50 centimeter, and in the final condition distance of this screen from the slit I am taking d2, which should be equal to d1 plus 50. d2 equals to d1 plus 50. d1 plus 50. Fine. And now what is distance between two consecutive bright fringes? Let it be x bar, and don't you know formula? X bar equals to lambda into capital D upon small d, and in the initial condition I am taking here d1, then here I am taking x1 bar. In the final condition I am taking here x2 bar, here I am taking d2. Fine. And now I want this minus this. If I want this minus this, it should be this minus this. Come on, x2 bar minus x1 bar, it will be this minus this. Lambda upon d is taken common. Inside the bracket d2 minus d1. d2 minus d1. Fine. Now what is x1 bar? First value of distance between two consecutive bright or two consecutive dark fringes, which they have given in the statement 0.03 centimeter. Later on that distance becomes double than this, it will be 0.06. Double than this will be 0.06. Fine. Lambda we are looking for. What about small d? Distance between two slits which they have given, come on, 1 millimeter. Convert millimeter into centimeter, multiply by 10 raised to minus 1. What is d2 minus d1 from here? Come on, d2 minus d1. d2 minus d1, it will be 50. It will be 50. So d2 minus d1, this gives you displacement of the screen, which is right now 50 centimeter. Because all the distances are taken in centimeter, naturally lambda will be obtained in centimeter. Answer is 6 into 10 raised to minus 5 centimeter. If at all you require to convert it into angstrom, you know very well now, centimeter to angstrom, multiply by 10 raised to plus 8. So multiply by 10 raised to plus 8. 8 minus 5, that is 3. 10 raised to 3 means 1000. 1000 into 6, that is 6000 angstrom. Correct? Now read statement of number 5. Read it. In the examination, you may not draw this figure. You may not draw this figure. Will do, no problem. But just for understanding, we are drawing this figure right now. Look, these are the two point-like coherent sources which emit light waves, say at time t equal to 0. Now, the light wave emitted from first source reaches point P, and this short distance I am taking as R1. Light wave emitted from second source S2 reaches point P and covers this much long distance, let it be R2. Because this covers short distance, it will take less time. Because this covers more distance, it will take more time. Come on, here I am taking time t1 suppose, and here I am taking time t2. Don't you know velocity of light wave in air or vacuum, it is shown by symbol small c, which is 3 into 10 raised to 8 meter per second. But you also know that velocity is always equal to distance travelled divided by time taken. Come on, this much distance is, come on everybody, R1. Corresponding time I am taking t1. Come on, for this light wave also velocity is c only, and distance travelled from here to here, it is R2 divided by corresponding time taken, let it be t2. And we also know that each wave takes capital T time to travel by distance lambda. You know, whenever distance travel is equal to wavelength of the wave, corresponding time is periodic time of wave. You also know that C equals to F lambda. C equals to F lambda. What is F? 1 upon T. F is 1 upon T. Got it? So C equals to lambda upon capital T also you can write. And now tell me, find out T1 from here. T1, it will be R1 upon C. T1 equals to R1 upon C. T2 will be R2 upon C. And capital T will be lambda upon C. Lambda upon C. Correct? What is given to us in the statement that the difference of time is equal to integer multiple of periodic time. Integer multiple of periodic time. So that integer multiple I am taking as small n. Fine. This is given to us in the statement. Now what is the value of T2? Value of T2 is right now R2 upon C, R2 upon C, minus T1. T1 is how much? R1 upon C. T1 is R1 upon C. This N as it is, capital D, come on, from here, lambda upon C. Capital D is lambda upon C. C getting cancelled. So it is R2 minus R1 equals to N lambda. R2 minus R1 equals to N lambda. Path minus path will give you path difference. So this path difference is equal to N lambda, which we know it is nothing but condition of constructive interference. Correct? Now here, let me show you this extra example. They may ask this example in the school examination. Okay? Fine. Instead of time difference equal to integer multiple of periodic time, they may give you this time difference, come on, half integer multiple of periodic time. Half integer multiple of periodic time, that half integer multiple I am taking this much, 2n minus 1 upon 2. Take n values 1, 2, 3 dash 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 respectively. Here, when you take 1, it will be 2 into 1, that is 2, minus 1 is 1, 1 by 2. 2, take n equal to 2, 2 to 4, 4 minus 1, 3 by 2. Take n equal to 3, 2 into 3, 6 minus 1, that is 5 by 2. So you will get, come on, 1 by 2, 3 by 2, 5 by 2, 7 by 2, dash dash dash. What are these values? Half integer multiples. So this is half integer multiple of periodic time. If they give so, then you can show that in this case, condition of destructive interference will be obtained. I am showing you. Come on, what is the formula for T2 right now? R2 upon C. Here it is, R2 upon C. Minus T1. T1 is R1 upon C. Come on, this part as it is. Capital D. Capital D is how much? Lambda upon C. Capital D is, come on, lambda upon C. C getting cancelled. So now it is R2 minus R1, that equals to 2n minus 1 into lambda by 2. Path minus path will give you path difference. And whenever path difference is 2n minus 1 lambda by 2, it is nothing but condition of destructive interference. Correct? So they may ask this. That's why I am giving you here extra sum. Okay? Fine. Now come on. Read this statement of number 6. Read it. They have given this figure, and using this figure we have to find out the conditions of constructive and destructive interference in terms of small d, in terms of capital D, and in terms of this part difference is in terms of small d and capital D, but conditions we have to obtain in terms of wavelength value lambda. What will be the conditions? I am showing you. Look. First of all, the light rays emitted from S will be just traveling this way. First light ray, you consider this one, S to S1, and then S1 to P. Correct? Second light ray, you may consider this, S to S2, and then S2 to P. Correct? Now you can see in the figure, this is a bigger distance. Correct? Bigger distance. And this one is a shorter distance. Then normally we take path difference, bigger minus smaller. Okay? So let us find out net path difference. Net path difference. It will be SS2 plus S2P, SS2 plus S2P minus, come on, SS1 plus S1P. SS1 plus S1P. Fine. Now just take subtraction this way. SS2 minus SS1. SS2 minus S1. You can separate it. Plus S2P minus S1P. Come on, S2P minus S1P. But SS2 minus SS1. SS2 minus SS1, that they have given in the statement 0.25 lambda. So this value they have given 0.25 lambda. What is S2P? What is S2P? Come on, it is R2. S2P is R2 minus S1P. S1P is R1. S1P is R1. And now tell me 0.25 means what? 0.25 means 1 by 4 into lambda, that is lambda by 4. And you know path minus path is path difference, and that path difference is xd upon d. x into small d upon capital D. Okay, instead of x I am putting xn, and you must write below x because it is a suffix. And now this is the net path difference. Now for constructive interference, this net path difference should be equal to n lambda, should be equal to n lambda. That is condition of constructive interference. Come on, transfer this. When you transfer this from plus, it will become minus. Take lambda common, inside the bracket n minus 1 by 4, n minus 1 by 4. And now lambda as it is, take LCM here, 4n minus 1 upon 4, 4n minus 1 upon 4, correct? So now condition in terms of condition for constructive interference, we have obtained like this, xn d upon capital D, come on, it is 4n minus 1 into lambda by 4. Similarly, let us obtain condition for destructive interference. For destructive interference, come on, same net path difference should be now 2n minus 1 into lambda by 2. Condition for destructive interference is net path difference should be equal to 2n minus 1 into lambda by 2. So just compare this with 2n minus 1 lambda by 2. Come on, same net path difference I have written here, lambda by 4 plus xn d upon d should be equal to 2n minus 1 lambda by 2. Transfer this from plus, it will become minus. And now lambda by 2 I am taking common. Left inside the bracket from here it is 2n minus 1, and because lambda by 2 has gone out, left inside the bracket from here it will be minus 1 by 2. This lambda by 2 as it is, correct? And now take LCM here, it will be 2 to the 4, 4n minus 2 minus 1, 4n minus 2 minus 1 upon 2, correct? Now tell me, 4n as it is, minus 2 minus 1, that is minus 3, and 2 to the 4. So it is lambda by 4, lambda by 4. I repeat, lambda by 2 as it is. Come on, take 2 as LCM. Here and here you can multiply by 2. So it is now 4n minus 2, 4n minus 2 minus 1 upon 2. Now 4n as it is, minus 2 minus 1, that is minus 3, lambda as it is 2 to the 4, correct? Here also it is lambda by 4, here also it is lambda by 4. What is the difference? Here it is 4n minus 1 and here it is 4n minus 3. This is condition for constructive interference. This is condition for destructive interference. Okay, fine. Now read the statement of sum number 7. Come on, read it. Tell me. They have asked to prove that the screen might be of infinite dimension. Then also, in this case, they have asked to prove that maximum number of bright fringes will be only 5, not more than that. Let us prove. See, we have to prove this result for bright fringes. Bright fringe, maximum intensity, constructive interference, path difference should be equal to n lambda. Path difference should be equal to n lambda. There are 4 formula for path difference, R2 minus R1, d sin theta, d tan theta, x into small d upon capital D. But here I am taking d sin theta, d sin theta. This is path difference, that should be equal to n lambda. But what is d? Distance between two slits, which they have given here 2 lambda. How much? 2 lambda, double than wavelength. Sin theta as it is, n lambda as it is. Now tell me, lambda will cancel. Take this 2 down, so sin theta will be n upon 2, n upon 2. You know the values of n, 0, 1, 2, 3, dash, dash, dash. Let us put one by one and let us see how many values are possible. For n equal to 0, put n equal to 0 here, 0 upon 2 will be 0. Put n equal to 1 here, 1 by 2. So sin theta equals to 1 by 2. Come on, put n equal to 2 here, 2 upon 2, that is 1. Come on, sin theta equal to 0, possible. Sin theta equal to 1 by 2, possible. Sin theta equal to 1, possible. But if any value is there greater than 1, then for sin theta it is not possible. If you take now n equal to 3 or greater than 3, put it here 3, it will be 3 by 2, which is 1.5, which is greater than 1. and if you take n value greater than 3, then sin theta will be greater than or equal to 3 by 2. For n greater than or equal to 3, sin theta will be greater than or equal to 3 by 2, but 3 by 2 itself means 1.5, which is greater than 1, not possible, because range of sine function is -1 to +1. That's why written in bracket, not possible. Okay, so this value is not possible, correct? Then which values of n are possible? 0 is possible, 1 is possible, and 2 is possible. That's all. For n equal to 0, you will get central bright fringe. For n equal to 1, you will get first order bright fringe. But those first order bright fringes will be 2 in number, 1 on upper side, 1 on lower side of central bright fringe. Similarly, n equal to 2 indicates 2 second order bright fringes. N equal to 2 indicates, 2 second order bright fringe, 1 on upper side, 1 on lower side, correct? Only central bright fringe is 1. Rest of the bright fringes are 2 in number, 1 on upper side, 1 on lower side. So we will obtain on the screen what? 1 central bright fringe, 2 first order bright fringes, 2 more second order bright fringes. 1 plus 2 plus 2, 1 plus 2 plus 2, totally 5. So in all, maximum 5 bright fringes will be possible on the screen. It might be of infinite dimension. We will not get more than 5 bright fringes. Okay, only maximum 5 in this case. Okay, when distance between two slits is given to you, double then wavelength. At that time, this result is proved that on the screen we will get maximum 5 bright fringes. Okay, fine. Here I have written, thus here 1 central bright fringe, 2 first order bright fringes, and 2 second order bright fringes will be obtained on the screen. In all, 5 bright fringes are possible in this case. Got it? Read the statement of exercise numerical number 8. Read it? Fine. Now tell me, they have given that at a particular point on the screen, 2 bright fringes are superposing. One bright fringe from first light and another order bright fringe from second light. They are superposing at some minimum distance from central bright fringe. That minimum distance I just assume to be x. Okay, fine. So I am writing here, if minimum distance of a point of superposition from central bright fringe is x, then tell me, for bright fringe intensity should be maximum, this interference should be constructive, and path difference should be equal to n lambda. Path difference is xd upon d, and that should be equal to n lambda. Okay, fine. Now tell me, because x is the distance of a given point from the central bright fringe, it is fixed, small d is fixed, capital is also fixed. Because this left hand side is constant, this right hand side also must be constant. Mathematically, when n into lambda is constant, we can write n1 lambda 1 equals to n2 lambda 2. That's what I have written here. Xd upon d should be equal to, from here, n1 lambda 1 should be equal to n2 lambda 2. Fine. Now just find out n1 upon n2. n1 upon n2, it will be lambda 2 upon lambda 1. n1 upon n2 equals to, lambda 2 upon lambda 1. n1 upon n2 as it is. Lambda 1, first wavelength they have given 6500 angstrom. Second wavelength they have given 5200 angstrom. 2 zeros getting cancelled. 13 4s are, 13 5s are. 4 upon 5. Now tell me, what is x? At present, what is x? Distance or minimum distance? Minimum distance. What is x? It is minimum distance. Because x is minimum, then here n also should be taken minimum. So you should go for taking minimum values of n1 and n2 such that ratio n1 upon n2 should be equal to 4 upon 5. And for that, minimum value of N1 is 4 and minimum value of N2 is 5. Somebody may think this way, suppose he takes N1 equal to 8 and N2 equal to 10 suppose. Then 8 upon 10. 8 upon 10 is also 4 upon 5. 8 upon 10 is also 4 upon 5. But 8 is greater than 4 and 10 is greater than 5. Okay. But if we take greater values of n, then x will be greater. We don't want greater value of x. We want minimum value of x. That's why we should take minimum value of n. Minimum values of n1 and n2 which can satisfy this condition are n1 equal to 4, n2 equal to 5. Come on everybody, n1 equal to 4, n2 equal to 5. Put either n1 equal to 4 here or put n2 equal to 5 here, will do, no problem. Let us take this equal to this now, come on. X into small t upon capital D, I am just equating with n1 lambda 1. What is x? Minimum distance, come on, that we require, and small t is what? Distance between two slits which they given 0.5 millimeter, converted into centimeter, multiplied 10 raised to minus 1. Capital D is the distance between slit and screen which they given 100 centimeter. N1 is 4, N1 is 4. Put N1 equal to 4, what about lambda 1? First value of wavelength is 6500 angstrom, converted into centimeter, multiplied by 10 raised to minus 8. Simplify, value of x is 0.52 centimeter. Okay, fine. So at this much distance from the central bright fringe on the screen, at that much minimum distance, you know what will superpose? Come on, fourth order bright fringe of first light with wavelength 6500 angstrom and fifth order bright fringe of second wavelength 5200 angstrom. They will superpose at that much minimum distance from the central bright fringe. Okay, fine. Come on my dears, let us proceed further in the numericals. Kindly read this statement of exercise numerical number 9. Come on, have you read it? Look, we have two point-like sources of light waves. They emit light waves which superpose at point P on the screen. The situation is like this, and we are asked to find out wavelength corresponding to that light wave which here produce first and second order destructive interference. Let us find out. This one is bigger distance and this one is smaller distance. Okay. This bigger distance is suppose R1, smaller distance is suppose R2. Now this is small d which is distance between these two sources, and this one is capital D which is distance between slit and screen. If this is small d, this is capital D, because this is right angle, this must be hypotenuse, and measurement of hypotenuse is square root of summation of squares of mutually perpendicular sides. So under root of d square plus d square, under root of d square plus d square. And now tell me, I want path difference, that is R1 minus R2, longer distance minus shorter distance, R1 minus R2. R1 is this, under root of d square plus d square. Under root, instead of under root I have taken power 1 by 2, come on, d square plus d square whole raised to 1 by 2, minus R2, R2 is nothing but capital D. And now from these two terms, if you take d square common, then inside the bracket 1 plus d square upon d square, whole raised to 1 by 2, minus capital D. Now d square square root will be d, and now square root of this I have written here, correct, minus capital D. Now this capital D as it is, and expand this term according to binomial theorem. In binomial theorem, don't you know, 1 plus x raised to n, 1 plus x whole raised to n. If x is very much less than 1, then in the expansion you can retain only first two terms, and higher order terms, because they are negligibly small, you can just neglect them in addition. So 1 plus x raised to n, it will be 1 plus n into x. First two terms are 1 plus n into x. 1 plus n into x means this into this. When you make this into this, it is d square upon 2d square minus capital D as it is. Here you can apply this binomial theorem because small d distance is very much smaller than capital D. So d square upon d square, this term is very much smaller than 1. Then only you can apply this binomial theorem and you can retain only first two terms. Okay, fine. Now d into 1 is d. This into this, come on, d is getting cancelled. So d square upon 2d. D square upon 2d minus d. d will cancel, giving you d square upon 2d. D square upon 2d. Now this is new path difference in the present case. Now if this new path difference equals to 2n minus 1 into lambda by 2, then destructive interference will take place. So for destructive interference, this path difference d square upon 2d should be equal to 2n minus 1 lambda by 2. Fine. Now just put n equal to 1. Put n equal to 1 here, so it will give you lambda by 2, correct? And here it is d square upon 2d. D square upon 2d, put n equal to 1. 2 into 1 is 2, 2 minus 1 is 1. 1 into lambda by 2, that is lambda by 2. Now 2 will cancel, giving you lambda equals to d square upon d. D square upon d. Now put n equal to 2 here. Come on. 2 2s are 4. 4 minus 1 is 3. 3 lambda by 2. 3 lambda by 2. This left side as it is. And now 2 will cancel. Find out lambda, transfer this 3 in the denominator. So d square upon 3d. D square upon 3d. That is the wavelength for second order destructive interference. Come on, this is the wavelength for first order destructive interference. This is wavelength for second order destructive interference. Got it? Now kindly read this statement of sum number 10. Come on, read it. We are given expressions of, come on, y components of electric intensity vectors or light vectors. Why we call it y component? Because there appears sign function, correct? For x component you just recall cos, for y component you just recall sine. Okay, fine. Now this is y component of first light vector. This is y component of second light vector. This is y component of third light vector. Fine. This phase is omega t. This phase is omega t plus 60 degree. This phase is omega t minus 30 degree. Fine. And now, just for the sake of convenience, you just take omega t equal to 0. Take omega t equal to 0. Correct? Why you can do that? Because here phases are not important. Phase difference is important. Phase difference is important. So if omega t is taken as reference phase, then as a reference phase you can just choose any value. So as a reference phase at present I am choosing 0 value. So this reference phase at present I am taking 0. So you can see this phase is greater than this by amount 60 degree. So if you take here 0, then here also will be 0. 0 plus 60 will be 60 only. And this phase is less than this phase by amount 30 degree, correct? So if you take here 0, 0 minus 30 will be minus 30, which is less than 0 by 30 degree, correct? So here phases are not important, phase difference is important. That's why you can take any value of omega t. I am just taking for sake of convenience 0. Just put omega t equal to 0 here. Come on, sin 0 is 0. 0 to this will be 0, so E1y is 0. Come on, take omega t equal to 0 here. Sin 60 degree is 0.866 into E0. 0.866 into E0. Take omega t is 0 here. Sine of minus 30 degree is minus 0.5 into E0. Minus 0.5 into E0. Now y component of resultant light vector is summation of y components of individual light vectors. E1y plus E2y plus E3y. So it is this plus this plus this. This plus this plus this. It is this plus this plus this. It comes out to be 0.366 E0. Fine. Now the way you have written y components, now we can write x components, correct? Instead of sine, you should write cos, that's all. Instead of sine, you should write cos. Now again taking omega t equal to 0 here also, cos 0 is 1, 1 into E0 is E0. Put omega t 0 here, cos of 60 degree sine 30 degree which is 0.5, 0.5 into E0, 0.5 into E0. Come on, put omega t equal to 0 here, then cos of minus 30 degree is cos 30 degree which is sine 60 degree which is 0.866 into E0, 0.866 into E0, correct? Now, x component of resultant light vector is summation of x components of individual light vectors. Come on, E1x plus E2x plus E3x, this plus this plus this, so it is this plus this plus this. This addition comes out to be 2.366 E0. Now we want magnitude of resultant light vector and that should be equal to square root of summation of squares of its mutually perpendicular components. Come on, under root of Ex square plus Ey square, under root of Ex square, Ex is this much, 2.366 E0, it's a square, then Ey square, Ey is this much, 0.366 E0, it's a square. Now E0 square you can take common and after taking square root you can take it out, that is E0, into under root of 2.366 square plus 0.366 square. Now square of this plus square of this and its square root comes out to be 2.394 into E0. Fine. Now just find out tan alpha. Don't you know? If alpha is the angle made by resultant phasor with reference line, then tan alpha equals to Ey upon Ex. Y component divided by x component. Come on, y component is this much. Y component is this much. 0.366 E0 divided by x component is this much. 2.3666 E0. Y x component is 2.366 E0. E0 E0 getting cancelled. This upon this comes out to be 0.1547. If tan alpha is 0.1547, what is the value of alpha? That you can find out from the table of natural tangents. It comes out to be 8.8 degree, correct? So you were asked to find out magnitude of resultant vector and phase also, correct? So now the resultant vector, the resultant light vector you can represent this way. For example 10, resultant light vector at any time t, it is equal to its amplitude multiplied by sine, correct? Come on, amplitude is this much, 2.394 E0. 2.394 E0 and why I am writing sine? Because in the given standard equations they had given sine function, okay? So sine of omega t plus the resultant phase which you got. Come on, phase you got how much? Omega t plus alpha you should write. Omega t plus alpha, where alpha has come out to be, come on, 8.8 degree, 8.8 degree. So because alpha is 8.8 degree, here you are putting value of angle in degree, this also must be taken in degree. Fine. Now kindly read this statement of number 11. Read it? Look. They are talking about maxima. Recall the condition for mth order maximum. Sin theta m dash equals to m plus 1 by 2 lambda upon d. But here wavelength they have given half of width of the slit. So lambda they have given d by 2. Transfer this to here. So d equals to 2 lambda. D equals to 2 lambda. Fine. Put here d equals to 2 lambda. Correct? D equals to 2 lambda. Lambda will cancel. Now this is 2m plus 1 by 2. This 2 will come down. 2 2s are 4. Now here what is m? Order of maximum. Take m equal to 1. Put m equal to 1 here. 2 into 1 that is 2 plus 1 that is 3. 3 upon 4. Sin theta 1 dash is 3 by 4 which is very much possible. But if you take m equal to 2 here, then 2 into 2 that is 4 plus 1 that is 5. 5 by 4 is greater than 1. 5 by 4 is greater than 1. Now sin theta value cannot be greater than 1. So if you take m equal to or greater than 2, then sin theta m dash value comes out to be greater than or equal to 5 by 4, which is greater than 1, not possible. I have written here, not possible, correct. So what is the only possible value for m? Right now only m equal to 1. Only m equal to 1 is possible means first order maximum is possible. But you know, first order maxima, they are on either side of central maximum, correct. So central maximum is always there, and on either side we have two first order minima. So one central maximum and surrounded by two first order maxima. One central maximum and other two first order maxima. So 1 plus 2, that is totally 3 maxima we will obtain on the screen. Might be of infinite dimension, of any dimension. On that screen we will get only 3 maxima, not more than that, okay. Now kindly read the statement of number 12. Read it? Look, in the examination, if you don't have time, you may not draw this figure, but try to understand this figure very nicely. Huh? Look, here is a slit. Just behind the slit, we have placed convex lens, and light rays, after passing through convex lens, they produce diffraction pattern, Fraunhofer diffraction pattern on this screen. Because this screen is placed on the focal plane, you know, distance of focal plane from the lens must be equal to focal length, and this much distance between slit and screen normally we take capital D. So right now this much distance is capital D, and this is focal length of the lens also. Right now D and F, they are nearly equal. Capital D is nearly equal to small f. Now if this is the intensity distribution graph, then from this graph you can make out that here it takes place, come on, central maximum. Here it is first order minimum, here also. Here is first order minimum, then second order minimum, then third order minimum. Now between these two, correct? Between these two, what is it? Between these two first order minimum, what is this? Central maximum. Between these two, what is this? First order maximum. Between these two, what is this? Second order maximum. So this much width will be, come on, showing you second order maximum. Second order maximum. And you require this much width, okay, fine. Now tell me, this is the angle corresponding to second order minimum, let it be theta 2. This is the angle corresponding to third order minimum, let it be theta 3. Now distance of third order minimum from central maximum, I am taking x3. Distance of second order minimum from central maximum, I am taking x2. And you are looking for this much width, which is nothing but x3 minus x2. If you take x3 minus x2, it will be this much distance, which is the required width of second order maximum, which we want. We want this much width, which is x3 minus x2. Let us find out now. Because you are talking about minimum here, recall the condition of minimum. Condition of minimum was this: sin theta m equals to m lambda upon d. In such examples, these angles of diffraction are normally very small. And if theta is very small, sin theta is nearly equal to tan theta. Sin theta is nearly equal to tan theta. So instead of sin theta m, I am writing now tan theta m. And that equals to m lambda upon d. But what is theta, tan theta m? Tan theta m means what? Opposite to theta m divided by adjacent to theta m. Take this as theta m, and opposite to that will be this much. Let it be xm divided by adjacent side. Adjacent side is this much, which is capital D, correct? Fine. Opposite upon adjacent. Opposite is xm, adjacent is capital D, right hand side as it is. Find out xm, transfer capital D. M lambda capital D upon small d. Now put m equal to 2. M equal to 2 here for second order minimum. Put m equal to 2, then here also m equal to 2, and then after you put m equal to 3. M equal to 3. M equal to 3. And now required width is this much. This much means how much? It is x3 minus x2. Come on, x3 minus x2. So required width of second order maximum is x3 minus x2. So it is this minus this. This minus this means what? This minus this. But when you take this minus this, 3 lambda d upon d minus 2 lambda d upon d will give you lambda d upon d. Fine. Lambda is wavelength of light used, 5000 angstrom converted into centimeter multiplied by 10 raised to minus 8. Capital D is the distance between slit and screen. They have given 100 centimeter, or it can be taken as focal length of this convex lens, which also is 100 centimeter. And what about small d? Width of the slit 2 millimeter converted into centimeter multiplied by 10 raised to minus 1. Simplify, answer is 0.025 this many centimeter. Okay, so this is the width of second order maximum. Got it? Just for your kind knowledge, remember, if they are asking width of central maximum, suppose you take double than this, double than this. Okay, so it will be 2 lambda d upon d. And if they are asking width of maximum other than central maximum, you take this much, lambda d upon d. It might be first order maximum, might be second order maximum, might be third order maximum. Other than central maximum, for any other order maximum, this much is the width. Okay, and for central maximum, width is double than this. Okay, kindly read the statement of number 13 now. Come on, read it. Tell me. The whole Young's experiment is immersed in a liquid. And now, in a liquid, you know, wavelength will be nth part of wavelength in air. Correct? So, in liquid, if wavelength is lambda dash, and if lambda is the wavelength of light in air, then lambda dash equals to lambda upon n. Come on, recall the formula for x bar. Distance between two consecutive bright or two consecutive dark fringes is x bar equals to lambda d upon d. But right now, because the whole apparatus is immersed in liquid, light waves will be passing through that liquid. Wavelength is not lambda now, it has been changed to lambda dash. So, I am putting lambda dash. And lambda dash is lambda upon n. Lambda dash is lambda upon n. Okay, fine. Now, tell me, lambda is wavelength of light in air, 6300 angstrom converted into centimeter, multiplied 10 raised to minus 8. What about capital D? Distance between slit and screen, that they have given 1.33 meter. This is refractive index of liquid. Let it be n dash. Let it be n dash. Let it be n only, no problem. This is refractive index of liquid, which they have given 1.33. 1.33. And what about small d? Distance between two slits, which they have given 1 millimeter, converted into centimeter, multiplied by 10 raised to minus 1. And now simplify. When you simplify, the value is 0.063. This many centimeter, because other distances we have taken in centimeter. Now see the second part. Now what have they done? In the second part, the whole apparatus of Young's experiment, they have immersed now in water. Fine. And at the time, one of the two slits is covered by some glass plate. Its thickness I am taking T. And when you are just immersing the whole apparatus in water, then here, come on, what was the net path difference at that time? If particular order bright or dark fringe is getting shifted and coming to the central bright fringe, in that case, what was the net path difference if you cover one of the two slits? What was the formula? Net path difference was T into mu minus 1. Come on, T into mu minus 1. But instead of mu, I am just putting mu GW, because it is now relative refractive index of glass with respect to water, because the whole apparatus is immersed in water. That's why. And then this net path difference you should equate with either n lambda or 2n minus 1 lambda by 2, depending upon the conditions given to you. Right now, it so happens that the first order dark fringe is getting shifted to central bright fringe, because they are talking about shifting of first order dark fringe. Dark fringe, zero intensity, district interference, path difference should be 2n minus 1 lambda by 2. 2n minus 1 lambda by 2. But instead of lambda, purposely I am writing lambda dash, because now this is not the wavelength of light in air, this is wavelength of light in water. which is different than wavelength of light in air, different than lambda, so I am just putting lambda dash, correct. Now they are talking about shifting of first order dark fringe, so N is 1, come on, put it here, come on, T as it is. What is this? Relative refractive index of glass with respect to water. It is nothing but mu G upon mu W, correct? Refractive index of denser medium divided by refractive index of rarer medium, fine, minus 1. And here, because N is 1, this part will become 1. What is lambda dash? Wavelength of light in water, which is nothing but wavelength of light in air divided by refractive index of water, correct? It is lambda upon mu W. And this 1 by 2, don't forget this 1 by 2, okay? Come on, T as it is. What is refractive index of glass? They are given 1.53. Refractive index of water is 1.33, minus 1 as it is. What about lambda? Wavelength of light in air, they have given 6300 angstrom. Suppose I want to convert into meter, multiply by 10 raised to minus 10. This is the refractive index of water, which is 1.33, and don't forget this 1 by 2, okay? Simplify, now you will get the answer as per the textbook. Thickness of the plate comes out to be 1.57 into 10 raised to minus 6, this many meter. Got it?